welcome back to another Sunday tool review. Today I'm going to do something that's a little bit more practical for the Street Fighter build that I have ahead of me. I'm going to be making a tail unit for this. As you know, the tail unit itself will be from sheet metal only. There'll be no subframe underneath it to bolt to, so the thing has to have, in various places, it will need holes punched in it in order to weld strength in. On the inside, you'll see that when time comes. Welding washers on the inside to make it strong to bolt to. All of that involves punching holes in sheet metal. And it will also be punching holes in curved sheet metal, and that's very difficult without distorting the metal itself. So I looked into a method of doing it, and I found something in the electrician's world of tools and equipment that just might help me with what I need. So let's show you what it is, and we're hopefully going to do a test on it to see if it does what it says on the packet. I'll show you what it is. Right, now, as these tools are generally used by electricians, as I said, for punching holes in circuit board boxes to put conduit through and that sort of thing, I thought the best place to find some was at RECON Electrical. So I'm going to pop a link underneath if you want to buy one of these for yourself. If you're going to do any sheet metal work at all, they will have a use. And they are, as far as I'm concerned, just about the cheapest answer to this problem that I could possibly find. Here we go, that's what they are. They're by a company called Q-Max, never heard of them. Q-Max sheet metal punch, and I bought a 25mm, so that's 1 inch, and a 20mm, that's 7/8. And the idea is this will make a handlebar size hole in a piece of sheet metal. You can see how it works. It's extremely simple technology. That little die, this is a sharp cutting edge with 3 points on it. That screws in there, and the piece of sheet metal is trapped in between. You drill a pilot hole in the sheet metal, and as you can see, that as you screw this down, it draws this cup over the top of the die, cutting the sheet metal. That's just about the simplest answer to it you could possibly have. Let me just show you a bit closer with that. Take the bolt out of the way. You obviously need a pilot hole. We'll have to drill that first, but just checking in on this again. You can see there, that is what they are. You've got the cutting die and the receiving cup, and that cuts into there. And the fact that that's a nice close fit, I hope, is what's going to prevent the distortion. Because normally, if you were to put anything on a piece of sheet metal that's going to then punch a hole in it, naturally it would distort it at where it punches it. So that cutting action into that cup is, I hope, going to give me what I need. So let's test that today. I'm going to start with the 20mm one, which obviously cutting a smaller hole is going to be easier. So we'll put the 25mm to one side, and we'll start with this one. What I want to start with, first of all, is a piece of 1mm sheet metal. So I'm going to test this. Look on here, and just kind of show them what we've got. What we have here, I've got some 1mm thick sheet metal. I've got some 1mm thick sheet metal that's from the fuel tank on the Kawasaki. This is the old fuel tank that I cut up to make the belly pan. So that gives me a curve. So I'm going to try and punch a hole in that curve, that nice gentle curve, in thin 1mm sheet metal, and I'm going to see if it will distort it. Also, this is 2mm thick aluminium, a nice curve, we'll cut that, see if that will cut a nice hole in that. This, on the other hand, is what I'm going to use. Now, this is the most important one for me, and this is the one I really want to result with, because this is 1.6mm. This is 16 gauge sheet metal, and at just over 1.5mm thick, this is what I think is going to be strong enough to make that tail unit. So this is the one I have to be cutting holes in, so that's the one I want the best results from, and it's mild steel. As well as that, just to push this test, hopefully to breaking point, I've got some 3mm thick sheet metal, which is what I made these bench tops from. So there might be a use for it. I'm going to see 3mm thick, mild steel. Who knows? It might work, it might not, it might break the tool. We'll find out in a minute. The other thing I want to check, is the most important thing, is stainless steel. Now, as we all know, stainless steel itself is way harder than mild steel, and it's often extremely difficult to cut holes in. As you know, if you're drilling holes in stainless steel, the drill bits don't last as long. And one thing, let me show you this, it's always an expense and a real disappointment, is these things. These are step drills, I'm sure you've seen them. You can also get the smooth ones, I think they're known as cone drills, and all you do with these, that is pushed into the sheet metal to cut the hole to the size you want. But they're very expensive, they blunt and wear out quite quickly, and they cannot be sharpened. They are a one-trick pony. Now those on stainless steel, you just burn them and beat them up in no time. It absolutely kills them. They are no good for sheet metal whatsoever. So let's see if this hole punch is good enough for sheet metal, a stainless steel sheet metal. And finally, the final test that I want to carry out today is on some mild steel tubing, because I'm going to be using mild steel tubing in the tail unit this size, and you'll see when the time comes. And finally, one I think is no way going to work. I don't think we'll get through this. This is 2mm thick stainless steel tubing. If it can get through that, I will be seriously impressed. But let's start at the beginning. The first thing is some plain old 1mm thick mild steel. So let's just check it first to give you, because this is a test and I want you to know that we're doing it right. So there's a gauge. Come on in, okay? So let's look at the width. And there we are, 0.9mm. So that's what you would term as 1mm thick. Just under 1mm thick sheet metal. Now I'm not going to use this metal for the project, but let's see. Let's give this little tool the best chance it can of proving itself to start with. Get in that corner. Little centre punch mark. Put it on there. Let's just drill a 10mm pilot hole to start with. Right, so here we are. There's a little washer just on there, does its job of allowing the bolt to slide round. Pop that through, and we put the cutting head on the back, wind it in till it touches the job. Now, because obviously these points here immediately bite into the steel, there really isn't much need to hold this. But if you do need to, it's got a couple of flats on it, and you can just put a simple open end spanner on that if it helps. But I think for now, we'll probably get away with this. Let's just turn that and watch that go through. Actually, let's do it that way, a bit easier. There it is. One hole in the metal, nicely done, perfectly round. The tool seems to be in pretty much perfect condition, and it's cut that perfect little piece of metal out as the waste. There we go. So there's the first test. We have made a 1mm hole, a 1mm thick piece of sheet metal, mild steel, perfect hole. No distortion? Well, no, not really. There is a little bit of a flute that way, where it's been drawn through that way, but not much. Not certainly anything that would cause a problem. So the next thing to test, I made a belly pan out of the fuel tank of the Street Fighter, and this is the back edge of the fuel tank. So it's 1mm thick, as you can see, very soft and flexible. Now obviously this won't have any trouble getting through it, but will it distort that shape, which is quite important if you're trying to retain that. So let's have a little hole in it first of all. Once we've got that, assemble it and see if it actually goes through nice and cleanly. There. Okay. It's all in. Let's cut away. Now that seemed to be extremely easy. There it is. Now I think you'll agree that has cut the hole with practically no distortion at all. So another little success there. Awesome. So now the next one, which I think is going to be a great test, is this. Now this is a little heat shield from the Harley when I bought it. I took it off because I don't need it because I've changed the exhaust. So this is a piece of 2mm thick aluminium, and it's curved. So we're going to see if it will cut through that without distorting it. There we go. Thick aluminium tubing, which is what that was cut from. One finger. Maybe two. That is going through extremely easily. There it is. Wow. Okay, so you can see on that one we do have a little bit of distortion. Aluminium being extremely soft. But look at the hole itself. Check how clean and smooth that is. Absolutely No cleanup required. And I don't know whether if I hadn't drawn that through from the other side, that might not have had the same effect. I don't know, but it's still working well. That's still a little success. Now the next thing, 1.6 mil, much thicker steel, going to be a bigger challenge. So let's drill a pilot hole and see if we can make this work. See if it cuts a hole. 1.6 mil mild steel. It's a lot more work. Definitely a lot more work. However, it's gone through. Again, nice clean hole, no burrs on it. You can put your finger in that and that is smooth as anything in there. No burrs, no filing, no cleaning, no burr either side. That's lovely. Really happy with that. And it seems that it cuts its way through and then it has to carry on all the way through. It doesn't come out on its own. Now it's starting to rub the blackening off, but there's no burr on the tool, there's no rough edges. Still looks good. Okay, next thing. Now I'm going to try, I don't think this is going to work, I really don't. This is 3mm thick mild steel. This is going to be a real challenge for this tool. I don't want to destroy the tool yet because I want to do the stainless steel, but I've got the 1-inch one for that if I need it. So let's see if this will go through 3mm thick mild steel. This is a real test. Let's see if it draws through. Now immediately, it's a lot harder. I'm going to go through a bit like a thread cut, just a bit at a time, rather than just try and wind it through in one go. Actually, I've got my doubts about this bit. I think that's going to fail. It's going through. Feel that popping through now. Lovely, we did it. Would you believe it?
Oh my goodness.
Actually done it. There it is.
Oh my god, it has as well.
Would you believe that? Absolutely astonishing. So there we are. That is conclusive proof that when it comes to mild steel, that is going to go through beautifully. And once again, that has cut a burr-free, super smooth hole with almost zero distortion. And that was some serious effort to get that through. So there we are. That's the next one. Okay, now we're going into stainless steel. Let's see if stainless steel stands up to this as well as it did with that. Okay, stainless steel. Should go through it nicely. A little bit more force, but nothing like the 3mm. There we go. Straight through, and again no distortion, absolutely burr free hole, smooth enough to rub your finger around with no danger. That's lovely. The next thing, I want to do a stainless curve. I'm going to use this old piece of mudguard. It is, as you can see, kind of a low grade stainless steel. It is stainless obviously because it's not rusty, but it's not super pure stainless. There we are. How's that? Again, on the curve there's a little tiny bit of distortion on the outside, but nothing to speak of. So I think if you're going to do it, drawing the blade through from the outside tends to cause this. Drawing it through from the inside is a little bit cleaner. And that is 1.6mm. So that's 16 gauge, 1.6mm mild steel tubing. So we're looking on this one for distortion. Does it distort it? Chew up the tube. or go through clean. Pop, 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 here we are. It's quite cool, you hear 3 distinct little cracks as the 3 flutes go through, but check this one. That's distorted that quite a lot. So again, you'd have to dress that perhaps with a little hammer and a dolly just to get it right, but it is a perfect hole. Again, nice and smooth. Okay, the final test for the 20mm is going to be this. It's a piece of high-grade stainless steel exhaust tubing. This is from the exhaust, the downpipe of the fighter build. This is originally a Micron exhaust. It's 1.5mm thick stainless tubing of just about the highest quality. It's probably 316. It's totally non-magnetic. That is as good as it gets, and that is really tough. Even to drill the pilot hole there, I had to use the drill bit and the cone drill to get that out to 10mm. But that's okay, that's quite easy. To take that out to 20mm, that is your only option. This is probably your only option, because if you went trying to use a step drill, that you burn it out. They do not work on stainless, especially stainless tubing. And I know that because when I did the scrambler heat shields and I bored the big holes in that to put the mesh on the other side, I probably went through 3 of these, and they're like £6, £7 each, a lot of money, so there's no point in wasting them. The other option is these, a hole saw, and that will go through, but it leaves a mess. Try it for yourself. If you believe one of these is the option to this, honestly, it's not. They make a terrible mess, and the super coarse teeth on these hole cutters, they will just catch on that tubing as they go through. They'll get 3/4 of the way through, start catching, start dancing around, and they'll just make a mess. You know, you'd be more accurate cutting the hole with a spoon. It's just a mess when it's done. So this is hopefully the only option to cut a hole in a piece of tubing. Now, if I'm going to do this sort of thing, if you know, cutting holes in tubing, notching frames, that sort of thing, this is the thickness of tubing you would use to build a frame. About 1.5mm thick, that's all you need. And if it's stainless, then cutting holes in it for notching purposes, that sort of thing, this could be it. 1, 2, 3, there we go. That's it, cuts the hole out. And again, it has caused that clear and obvious distortion. There's no way that I could have mounted that the other way and cut from that side, because I couldn't have turned that from the inside. However, the test here was to prove, first of all, whether these knockout punches are strong enough and sharp enough to, first of all, cut the hole you need to cut in the material that you want to cut it in, and secondly, to last. I mean, that's warm to the touch. That is definitely, that tool is getting practically hot to the touch. It's done a lot of work, and there's practically no damage to it whatsoever. There's a little tiny nick just there. Can you see that, Ben? Just a little nick on that edge, but you can't. Yeah, you can, just about. Just feel that little nick there. That's the only damage. And when you look at what we've done, we've cut 1, 4, 5, 6, 7, 8, 9, 10 holes in all kinds of metal. And the biggest challenge today, without doubt, was the 3mm thick mild steel. That was the biggest challenge to cut through, and it did it in good fashion. So what I'm going to do is a final test. I'm going to use the 25mm, the 1-inch. I'm going to see if I can cut a 1-inch hole in this 3mm steel. This was the hardest to get through of all of them. So let's see if this is a final test and this works. Let's line up the 25mm. This is 1 inch, and I will be cutting 1-inch holes in the job that I'm doing. And give it a chance, because this is going to be a lot of pressure on it. I'm going to lube that up. Now, it doesn't say anywhere in the instructions that you have to do this with the thread, but obviously this thread is being pushed to its limits. Through that thread, you're trying to draw one against the other through this steel. Extremely harsh. Why not give it every chance of survival? Lots and lots of effort. There's one of them pop through. You can see it coming through at an angle. 2. There it is.
Oh my goodness.
Wow. Now the only significant, let's get that bit out. There's a little bit of waste. There is that. I don't think you need more proof than that. Look at it, 3mm thick piece of steel, twisted into that shape and chopped clean out. Absolutely just incised it and sliced it out beautifully. I love that. Now the receiving cup, absolutely perfect, flawless, not a mark on it. A little cutting die. Again, this is the first use of this. It's the first time it's been used. It's brand new and there's not a mark on it. This one, the other one we've put 7 or 8 cuts through, all these different metals, including a piece of 3mm. Again, one little nick on it just there. Other than that, immaculate. The only casualty on this has been that bolt. Where I've put so much pressure in it to get it through, it's bent that bolt. It's just a little kink from there. But I don't think that last cut was a fair and reasonable test of the tool. These are not designed to cut 3mm. I just wanted to get to a point where it doesn't cut. And I think we could say if you went for 4mm or 3mm stainless, you wouldn't go through that at all. You'd break the tool. I think this bolt would be the first casualty. That would snap at some point. It truly would. I'll take that out before I walk into it. As far as the tool is concerned, it is exactly what I need for what I'm doing. If we look at step drills, you've seen those in use today. They catch and drag and skid and they leave jagged holes. They do the job, they're fine, lots of people use them, but they are not by any means as good as one of those. So that's definitely a second case. That one, well, hole saws, we all know what hole saws are. They do work, but again, these big teeth catch and drag, so they, again, are they going to be second rate compared to these? There's no way they go through as cleanly and neatly. And drill bits, obviously a drill bit in sheet metal just doesn't work. It leaves a triangular hole, it drags and catches, and anything over 10mm, 12mm at a push in sheet metal, you really should be using a step drill. So there we are. In the sense of the best option to cut in holes in sheet metal without using expensive machinery, these little things. Little standard sheet metal punch, or knockout punch as they seem to be called by the trade. They are lovely. I absolutely love those. What do you reckon, Pam?
That was cool, wasn't it?
Really cool test. There they are. They're £7 or £8 each. That's all they cost. They're really cheap and affordable. Like I said, I put a link underneath to the company that sells them, or the company I got these from. The brand of them is QMax, but they don't seem to have their own site, so I just got them from RECON. And again, like I said, link underneath if you want to buy yourself some. You just check out what sizes you need. I got 20 and 25. I think what I might do to go with those, which will go in the toolbox now, I think I'll get probably a 15 and maybe a 20, maybe a 30. So I've got a nice range of different sizes. And what they're going to be for is on the sheet metal, when I weld strength on the back of it, I want to cut a nice big hole, then weld a washer on the back, and that's better to bolt to. If you bolt a bolt and a nut to sheet metal, it can crack in the future. It's better to cut a big hole out, weld a washer in there and bolt to the washer. It's a safer way to do it, but we'll cover all that when the time comes. Today was a little test of these punches to see if they work, and for 7 or 8 quid each, they're an absolute marvel. I love them to bits. What do you reckon, Pam?
That was cool.
Super. There we are. Thanks for watching. Take it easy, ride safe, and we'll see you next time.
All along the wire, lighting posts 50-foot high. Through the fumes and haulage, it's sometimes hard to know if the prize is stateside of New